the default use for intelligent technologies, think AI and robots. The scaling factor is that it allows an expert to do more work faster or better. The primary relief valve there in terms of your gained productivity is that you no longer require the help of someone with less skill to get the job done. The novice doesn't get a chance to participate in the work in a meaningful way. I saw this up close and personal first in robotic surgery, where the device itself meant that the surgeon can do the entire job himself. That meant the resident, who is the apprentice in this case, is strictly optional. And then the surgeon has to make an elective decision as to when they want to involve someone who is slower and will make more mistakes. When's the right time to do that? Never. And so that compromised most residents' skill. And that's the general effect that we should expect and now shown across numerous contexts.
Welcome to the Work for Humans podcast. This is Dart Lindsley. Take a moment and think about your most valuable skills. Where did they come from? While we do gain knowledge from formal learning and education, true mastery tends to come from working closely with experts who can pass down their skills. As AI and automation reshape the workforce, the traditional way we pass down critical skills is under threat. Junior workers are losing the opportunity to learn directly from experienced mentors, putting essential human abilities at risk. Matt Beane has spent a decade conducting field research into how expertise is passed down and how technology can get in the way. As a leading researcher in machine intelligence, his latest book, The Skill Code: How to Save Human Ability in the Age of Intelligent Machines, uncovers the hidden dynamics of expert-novice relationships and explains why preserving these bonds is crucial for thriving in a tech-driven world. He also tells us how some novices hack the system to learn faster than their peers. Matt is an assistant professor at UC Santa Barbara. He's known for his groundbreaking research on the impact of robotics in the workplace. He holds both a PhD and a master's in management research from MIT's Sloan School of Management, and he's also a digital fellow at both Stanford and MIT. In this episode, Matt and I talk about the impact of tech on workplace learning, technology management programs, and whether technology shapes human behavior or vice versa. We also discuss using tech for scale development, the difference between knowledge and skill, using positive deviance to grow at work, human capital development's connection to productivity, and other topics. All right, as always, if you enjoy Work for Humans, don't forget to subscribe to show your support. And now, I hope you enjoy my conversation with Matt Beane. Matt Beane, welcome to Work for Humans.
I am delighted to be here, really excited to learn from each other.
So as we were saying just before this call, I've spent a lot of time asking people what they want from work. Hundreds and hundreds of people what they want from work. And one of the things that I would even say most people say is they want work to help them learn. Well, you've identified a flaw in our future, essentially. It's the way in which technology is intervening in our ability to pass knowledge from generation to generation. And so I want to get to that, but I want to start just a little bit farther back, which is you are with the UCSB, University of California, Santa Barbara Technology Management Program. And I seem to remember that MIT had something like that too, but I don't really know what technology management programs study.
And we recently became a department, thankfully, after a long administrative slog through the UC system's thicket of requirements. Technology management is a useful label because it means nothing and anything. But practically, I think the structural situation we're in actually answers the question. So we're embedded in an engineering school, not a business school. And it was established originally as a finishing school for engineers to go off and found companies because their advisors were getting annoyed at having to tell them how to do that. So a shadow curriculum emerged, and then it became formalized. And we're talking like 18 years ago, 16 years ago. No one did research in my department. And it was a program. It was just a set of classes you took from venture finance to management and so on. Then came this moment where it was realized that this was a distinctive and latent capability. And there were people who actually, like me, did research about technology and its role in how organizations are founded, created, and run, as well as innovation in the economy and so on. So in, let's see, something around 2014, research faculty were hired. There was a big move to turn it into, well, wait, this is a center of excellence in the world. It turns out there really aren't very many research departments. Stanford has had one for decades. MIT has had another. That's the one I came out of, which is the information technologies subspecialty at Sloan, which is a three-part blend of economics, sociology, and computer science. So that's what I came out of. There are very, very few places that somebody like me could land and be able to express myself in a CS related paper or a building oriented paper, a sociology or economics journal, doing work across those three. Stanford was one of those places I could have landed. UCSB, thankfully, because faculty from Stanford and their students were recruited down here to start version 2.0 of the center up at Stanford in management science and engineering. That to me became Camelot instantly. My heroes were here. I wanted to be here. But anybody who's here in some way, shape, or form publishes sterling work about how humans organize to get stuff done and how technology changes that, or the implications of tech for that, in management type journals, as well as, Chi papers, or I'm a human robot interaction guy. So I did a lot of my empirical research on robots. So I would go to those technical conferences and so on. And that would be viewed as wildly inappropriate at a business school. It just wouldn't count for anything. So there are very few places where I could land and really be my whole darn self. And this is one of them.
Fantastic. It's great. So first of all, I don't feel horribly ignorant for not knowing about it because it's not very common. But also, what in the phrase that's nice is that it's technology management program, and that it's not necessarily the management of technology. It's also how technology influences management and vice versa. And in fact, you have a paper which was talking about the pace layers. It essentially reversed the relationship between technology and management. Can you summarize that?
I love that you dug that up. So one of the critical problems in social science around technology is whether it's figure or ground, basically. Whether it's the agent or the actee, the actor or the actee. And there are lots of theoretical approaches to that. If you look up close at organizations and you gather primary data on how people deal with technology, it is often very difficult to make causal claims about whether the tech is affecting and shaping human behavior or vice versa. So anyway, we've never really solved this problem. In fact, I think it's an unsolvable problem, but we always tilt at the windmill about once a decade. And Paul Leonardi, who's the chair of my department, he came out of Stanford and then went to Northwestern and then came here. He and I decided it was time for a fresh take on that. And in short, I had come across Stuart Brand's sort of appropriation of the pace layers framework, which of course came out of architecture and building design and considerations of building maintenance.
Can I just explain, because we haven't talked about this on the show yet, about the idea of pace layers. Stuart Brand wrote a book, which is, I believe, How Buildings Learn.
Yes.
And what he pointed out was that you put a building on a site and different parts of the building will adapt at different rates. The land never really adapts. The building itself, the foundation of the building, very stable, but not as stable as the land. And as you go up through these pace layers, what you find is that there are different rates of change in the building. So for instance, the furniture can move around very quickly. The walls can move around slightly less quickly, but also that they inform each other, that there's a communication between these layers, but they move at independent paces.
Exactly right. And they condition each other. Originally, this came out of ecology, basically, studies of complicated ecosystems where you'd have tectonic plates moving around, and that's a very, very slow moving, high inertia layer that has no practical relevance to a hummingbird, which has no practical relevance to a microbe. And the redwood and the hummingbird are probably insensate with respect to one another, but the behavior of each conditions the other. The basic covering law in a pace layer-based system is that which is slow and has high inertia conditions that which is fast and has low inertia. In general, the causal control, so to speak, flows from those deeper, harder to change layers, and they condition what's possible at the faster moving layers. And there are fascinating exceptions where, for instance, there's a great study of a red couch at IDEO, which was a treasured artifact of one of the founders, and that folks literally rebuilt the building and avoided touching, moving, reorienting that red couch. So the entire organization's substrates, the infrastructure that you would assume, and it actually was in dollars and cents, extraordinarily costly to re-engineer. They did to make sure the red couch. So culture, in fact, which is very ephemeral, almost fashion-based, the fastest moving pace layer can sometimes invert its relationship. So anyway, we just thought it was high time to think of the technology as breaking out across the moral equivalent of pace layers in organizations, where some kinds of tech are the equivalent of the HVAC system in your house, HR systems, systems of record, SAP, Oracle, what have you. And those are very difficult to modify wholesale, to maintain, to get access to once they're installed. And it explains a lot, if you think of it that way, about what's possible inside an organization if you're going to try to implement some new tech, if you have that HVAC system installed, basically. So that paper just explores the implications of that. If you think of technology as breaking out in that way and human behavior as having different effects at each of those layers, then what kinds of different predictions could that help us make about how and why technological change happens or doesn't?
I have commented on the show a couple of different times that we are often completely controlled by our data models, and that our data models are something that can make us do the stupidest things as companies because they are very slow moving and they are the context in which we have to manage. And yet the world in which we manage changes much quicker than our data models. And so it's a good example of that.
That is why in the last year and a half, I've become a measurement guy.
Oh, yeah.
With respect to the entire conversation implied by my book, for instance, I talk in the last chunk of it about what we could do with currently available tech to make a brighter future than was ever possible before with respect to skill development. And I missed, I think, the key foundational, if it's a pace layering, to use that analogy, the foundational move is to introduce a cost-effective measure of these effects so that firms can see it and judge for themselves, so that individuals can get their own relatively inexpensive data about the trade-off that they may or may not be making in favor of productivity over their skill development. We just don't have a way of getting that data. So, in fact, perhaps the highest good I can do is to develop a metric that people can use and then not be able to unsee that trade space between those two things.
Fantastic. Well, let's start down the path that leads to that discussion. I'm going to summarize and misstate the way I see your work, probably,
Excellent.
which is we spoke a little bit ahead of time about the work of Edwin Hutchins, and he looked at collaboration in the wild. He was somebody who studied how groups of people actually get things done. He was a cognitive anthropologist, is what he was. But what he was looking at was a group of people who were static. They were already in place and they were already functioning together. What you have looked at is more dynamic than that. It's how those groups, both people and intervening technology, learn together and grow together. And so, what is historically, how has knowledge passed down from expert to novice?
Well, and I think you just answered it in part, but I have succeeded thus far to the extent I have by being a pedantic nerd. So I'm going to do this right now with respect to the difference between knowledge and skill. You said knowledge, and that's often, especially in economics, used as a proxy for skill, like synonym. And it is not. Knowledge It's useful scientifically to treat knowledge as conceptual awareness or understanding, which is very distinct from the ability to reliably produce a valuable behavior under pressure. That's skill. So, knowing what a good golf swing looks like is knowledge. The ability to do it in the rain while somebody's yelling at you is skill. And I think both can be transmitted through the same mechanism. One of the most delightful discoveries as a part of writing my book was the archaeology of apprenticeship, which is a deep and extensive field. And in fact, the oldest studies there are of phenomena that occurred 160,000 years ago. There is firm, clear, repeated archaeological evidence of the work, sort of the exhaust associated with the work required to produce a bow and arrow, the first stored energy weapon in the history of our species. And you can see from piles of rocks, basically, that no one human being is capable of manufacturing a bow. You would die trying because you have to gather quite a bit of resources from the environment, everything from stuff that would have degraded, feathers and wood, to flint and other kinds of stone. You have to gather that, then you have to bring it to a spot. You have to transform it through a series of processes, very coarse transformation and then fine transformation. And no one human could even do two steps of those chain, even today. This has been tested. So they send bands of, it's usually white dudes who love to go to try to replicate these things in the wild. But bottom line, there are groups of humans. It's the limits of our biology, our cognition, our morphology that mean that we have to cooperate to get complicated stuff done physically. And that means usually the younger, stronger people are going to gather the raw materials, bring those to a location. They are transformed by slightly older, more capable individuals, and then handed off to people who do the sharpening of the tips and attaching to an arrow and so on. So if you buy that, what that tells you definitively is that younger people typically were less skilled, but got a chance to help in the work of building a bow. And by the repetitive helping day in, day out, they worked their way up the chain so that by the time they were 5 years older, they were sitting and somebody was looking over their shoulder. And we have evidence from that. And that's right about when humans came up with language. So that's far older than any formal transmission method of anything you might constitute as knowledge. And we have lovely, like very rich archaeological evidence of this process in ancient China and Greece, in particular, around everything from pottery to sculpture to weaving, even like non-durable goods, just from depictions of that work, and actually notes home to mom on lead scrolls from a beleaguered apprentice that were buried in a well. So all of that predated school, as we like to think about it, formal instruction. Of course, that came along, language, writing, graphic depiction, and encoding of expertise, critical enabler of what we're able to do now. So we can go further, faster, better, exponential gains. But the bedrock for how you actually learn to reliably produce valuable output under pressure remains and has been, even through Hutchins' day up till now, that interaction between an expert and a novice. People are quick to use the terms master and apprentice there, which is a vanishingly small subset of those interactions. That's a sort of very long-lived interaction that's formally recognized, sometimes instantiated in law these days, or policy. The universe that I'm speaking about could be interactions that lasted just a few moments or minutes, even. You're trying to solve a problem with an expert, you know less, they know more, and in the doing of the addressing of that problem, you build skill. The research is very, very clear on that and has been for decades. We just take it for granted is the right way to talk about it.
How is technology interfering with skill transfer from expert to novice?
The main thing to say there is there's two amendments I'd make there. One, tech isn't doing anything.
Yeah, that's true.
Right? Again, this is the pedant in me is coming out. Humans use tools to do tasks. That's the functional form in the world and has been. That may be changing. We might be in the middle of things changing there. It seems like they are. But up until now, we build, test, commercialize, and then put to use and maintain technology. That's what humans do. And it's those patterns that shape outcomes. You can design tech in a way that makes it much more likely that humans will use it in certain ways. So design has quite a lot of disproportionate influence on what ends up happening. So that I am very quick to say, though, that especially since my primary data for years now has been observing humans doing work with technology or deciding to buy it and how to deploy it, there is no moment in which you can gather data that shows that technology is causing anything of consequence. So that's important to say. And the default use for intelligent technologies is the label I use in the subtitle of my book, Think AI and Robots, is that the scaling factor is that it allows an expert to do more work on more complicated problems faster or better. And experts delight in that in general. You are an expert in various areas, so am I. The more complicated problems you can solve, it is intrinsically motivating and satisfying to do that. You feel more valuable, powerful, competent. That's a base drive. So experts will take that deal. Organizations love that deal because one expert is costly. And if they could do more valuable work in less time, then I'm going to be delighted with that new investment. However, one of the primary mechanisms, this is I found in my research and now I've seen in over 30 contexts across the economy, different technologies. The primary relief valve there in terms of your gained productivity is that you no longer require the help of someone with less skill to get the job done. This is the equivalent of being able to build a bow with no help. What that does for the expert is more bows faster. The novice, however, doesn't get a chance to participate in the work in a meaningful way and learn in this informal, taken for granted way. I saw this up close and personal first in robotic surgery, where the device itself meant that the surgeon can do the entire job themselves. And that meant the resident, who is the apprentice in this case, is strictly optional. And then the surgeon has to make an elective decision as to when they want to involve someone who is slower and will make more mistakes in a surgical procedure. When's the right time to do that? Never. That is the correct time. Unsurprisingly, in most cases, residents saw dramatic drops in their ability to actually meaningfully participate. They got to watch surgery a lot, but you could do that on YouTube. And so that compromised most residents' skill. And that's the general effect that we should expect, and now shown across numerous contexts, that we should expect with these technologies in the default use approach, basically.
And I kind of want to part out skill acquisition a little bit. And this is me being irrelevant but curious. Some skill it seems to be in the eye. Some skill seems to be in the hand. Some skill seems to be conscious and in the conscious mind. And it seems to me that they all have to work together, I suppose, is the answer. And so any one of them being interrupted in that situation that you described is a problem.
Yes, and there are some places where it's much less of a problem because your primary function is diagnosis. Andrew Abbott is a foundational sociologist who did some really critical work in the 80s and 90s, showing the sort of nature of professional and occupational work. And he really focused on this three-part cycle that most occupations deal with. One is about diagnosis, another's inference, and the third is treatment. You can think of that as a cycle. Diagnosis is what empirically am I encountering right now? Just noticing the phenomena. Inference is referring that raw reality to some dictionary of problems that is associated with my area of expertise so that I can classify it, so that I know how to handle it. And then the treatment is the intervention. So in almost all cases, that loop is just a continuous one. And the treatment effect is maybe less overt or less consequential in some professions, like a radiologist, for instance, doesn't actually intervene in the cancer, right? But they need to make a judgment. They levy a judgment and they send off that judgment. That's their intervention, so to speak. But it's quite light, I grant you, compared to a surgeon. So I think there's interesting and unexplored questions there about what difference different technologies make for professions or occupations where the emphasis on one of those three is greater. I don't think we have research on those questions.
Okay, that's great. We could go deeper into the issue as you have seen it. Let me talk about the consequences for a second of an interruption in the passing down of skills. If it's broad, there's probably a name for this, but I've been wondering a lot lately about the resolution of the economy. Here's what I mean. When you have 100 people, your economy has only so many pixels of skill. But when you have 10 billion people, you can have people who are highly, highly, highly specialized. And we've become incredibly dependent on this very high resolution economy. So, is there a name for that? And then, second of all, does this pose a threat?
Not to my knowledge. That's a fascinating question. I'd have to go check. And I don't think it matters in theory. The kind of problem that I have encountered in my research, this breaking of this taken for granted skill development engine that actually undergirds our economy and the way we build knowledge and expertise in the world, that would matter if we had a low or high resolution economy, I think, in that sense. It's just that in a very high resolution economy where talent is quite mobile and you have a lot of dynamism, like new technologies, new tasks, new possibilities coming in constantly, some fading away, the whole system is incredibly complicated. It's going to take longer. There will be a longer lag before you start to notice the effects of these breaking of this chain. And it might be masked in some cases or make no difference at all when talent is quite mobile and can shift to different problems. So it's not at all obvious the effects that it's going to have in some sort of coarse way. I can say that if you take for granted the argument up till now, which is asking a lot, actually, anybody just listening to this podcast is like, really? Is this really going on in the entire economy? The middle third of my book pulls together all the research I could find, including my own, to mount that argument. And if you're skeptical, I would say go there. But the main thing is, if you assume that's happening, then in any garden variety occupation, profession, organization, you should expect, after you nuke that connection, make it optional, that a novice is involved, there's probably a 2 to 5 year lag before those novices come washing up on your shores, so to speak. They land in a role where they should be fit for duty as an independent expert, and they will not be ready. And that has happened in robotic surgery now. So I can speak about the effects there, which is that somebody leaves a 5-year residency as a urologic surgeon, and they've had robotic training, I'm doing big air quotes here, in which they basically just watch TV. And of course, they got some practice, but they're not confident or competent. They arrive at a hospital that has bought one of these machines and is looking for ROI on that machine. That person is legally empowered to use that machine, and they will then be expected to operate and are not yet ready. And that means that hospital takes a senior expert offline who can do the work and plunks them in the OR with that person for the first 3 to 6 months of their operative time at the hospital, which is a huge hidden cost for that institution. They call them proctoring or proctorships, or they call them sabbaticals sometimes. They have different names for this, but it's basically remedial training. So I don't know how the economy is going to manage this problem, but if results are paramount and you're not willing to compromise on value, then somehow somebody's got to find a way to get good at the problem.
And the measure that you provided in that particular scenario was number of hours it takes to do the operation. Somebody who's skilled with the machine can do it in 4 or 5 hours, and that's good because hours under sedation are dangerous. And yet the novice comes in and it takes them 10. And so I think it's actually really important not to look at aggregate outcomes. There's an immediate outcome, which is a risk to somebody's life in that scenario. And there's something that you said, which I want to point out, which is referring to learning as the exhaust. It is true that learning is the exhaust when we don't consider the value the learner gets, the novice gets from the learning. And so if we look at the system as one that's producing multiple kinds of value, not just good surgery, but also the value to the person who works there, it's not exhaust. It's healthy protein food, or something. So what it means is that even in the time where the expert surgeon is amplified and is able to do more operations and everything's good, we have lost value in real time.
Yes, agreed. And no one is quite equipped to notice that or to intervene to change that. That's the primary problem I think we have right now. So yes, I think exhaust is the wrong term. I think probably just to be dry and empirical about it, work has many outputs, one of which is typically accounted for in productivity metrics like throughput times quality. And another output of work is skill development. And relatedly, I get into this in my book, in the first third of the book. Another output of work is the tenor or quality of the human connections and bonds of trust and respect between human beings, which are integral to your skill development. I get into that in the book as well. So, work has many outputs. Some of them we measure and value in currency and can quantify readily because we've developed practices for that and so on. But that doesn't mean there aren't other outputs and that they aren't valuable. That novice, by the way, I can speak now from numerous cases across the economy. You would think they're the ones who could complain and raise a stink about not getting a chance to get up to bat anymore, but they don't have a basis for comparison. One, they're new. They don't know how it used to be. And they're just trying really hard to get ahead. So they want to make the most out of the opportunity in front of them. That's their primary objective. So that's problem number one. Problem number two, though, is that they have very little power in that system. They are, by definition, supposed to be compliant because they are entrusting their career to that system to advance their skill. It's a very rare medical resident, say, or investment banker, or beat cop, or surgeon, what have you, who can notice in advance that there are threats to their skill development before taking the gig and ask some smart questions or just walk away from it. Savvy residents did, by the way, by the time I hit the field, it was probably 1 in 20, maybe 1 in 15, who would, before they took their residency, because they have choice, they would say, how much time am I going to get controlling the robot per procedure? So they'd already figured this out. But you have to have a lot of privilege and social connection in order to even understand that that's a problem. That's not a sustainable way of approaching it.
You speak a lot in the book about what it takes to develop skills. And it takes challenge, which, by the way, is often uncomfortable. So, as a novice, I might actually like that I'm not feeling that. So, there's challenge. It needs to be a bit beyond your ability, and it needs to be in a complex environment. Can you explain that? Because that surprised me. I think of learning as, if we're going to learn something, let's bring it down to the simplest thing so there's no noise in the system, and we're just going to focus on that thing.
Yep, that's the paradox. And it is a paradox. I don't want to try to resolve it. So to take one step back, the title of the book's The Skill Code, obviously, and the first third of the book is the skill code. And there's a DNA, there's a double helix on the cover of Humans and Machines. The idea is that in the same way that we've got amino acids for DNA, we have 3 atomic units of skill development that are combined in different ways in different contexts for different reasons that end up producing skill. But you can count on those 3 things being strictly necessary for healthy skill development. The first one is more intuitive, I grant you. That is, it can't be easy. You have to be working close to the bounds of your capability, not at them or beyond them, but close enough where your performance is actually lower than it could otherwise be, and you're totally focused. I have surgeons who were sweating in the control console. That's a good sign. That's a good sign that you're close to your edge of your capability. Complexity, though, is, as you say, engaging with the broader universe of activities, roles, human beings, material, and systems that you're embedded in to do your work. So to concretize that, if you work in a restaurant and your job is making sauces, in a spare moment, you look left, you look right, and notice, okay, what are the stations left and right of me? Fine. But what about that refrigerator unit, that new flash freezer that we got? How does that work, right? A technological question. Or if you're so inclined, what about the finances of this restaurant? How do we make money? Or how is this team working together? How does that work as a unit? You're embedded in an extraordinarily complicated system, and there are different people who are stewards of different parts of it. But real skill means, like I said, the ability to reliably produce results under pressure. Pressure equals variation, surprise, dynamism in the work. And if you understand the broader universe of those skills, practices, and everything, like what season are we in at that restaurant? Is it fall? And what does that have to do with how I make this soup? If you know that, you're more robust to those shocks that come with the seasons. Whereas a rookie would be like, I'm just trying to reduce this sauce and it's not working today. Why in the hell not? A seasoned vet knows, yeah, it's because the temperature of the stock as it came in the building was different because it's cold outside and I've got to take this extra step, right? So engaging with complexity is something that anybody in a healthy longer term journey to skill ends up doing so that they can pivot and also they can manage a growth oriented career. You've been running a production line for a while. What's your next move? Well, if you've been paying attention to complexity, if you've got a healthy exposure to that, you might know that shipping and receiving is an interesting place to go for you next because you're curious about the building as a functional unit and how it manages inputs and outputs. Or you might want to go to finance. But you can't get there unless you've had that healthy encounter with that complexity.
That's why at the beginning you said a skill is the ability to hit the golf ball in the rain on a muddy slope. It's because you know what? The truth is, we're always in some way in the rain on a muddy slope. I often have said this to my team. That's not friction in your job. That's your job. That's not extraneous to your job. So that makes a lot of sense. And then the threat to connection. And that is those trusted relationships. I want to get into the exceptions you've seen, where you have seen novices exhibit behaviors that actually made them successful as learners.
Yes, in spite of all these barriers we've been going on. So this is not anecdotal. I designed my studies deliberately to do sort of a two-phase move in every study. Phase one is base condition, which you should expect waste, failure, and harm with respect to skill development and new tech. That's basically what you should expect in all cases. So articulate that, show how it works, and find a few cases that look consistent with one another that might be indicators of exceptions to the rule. Phase two of the study is you have a hypothesis about success in conditions where you would expect failure, and then you go deliberately try to sample on that systematically, but in a way that blinds you to what you're doing so that in the case of surgery, I then went to 13 additional top tier teaching hospitals, asked to be connected with surgical residents, one of whom was learning an incredible clip, like a few that I had found early, and developing strong skill, and another that was strictly average, but don't tell me which is which. And I want to interview them extensively and then unblind me after I do that. If they are getting ahead in ways that are roughly comparable, and I can show empirically that they are not consulting with each other about how to do that, then I've got my hands on a set of ways to build skill in conditions that are hostile to traditional means of developing skill in this expert apprenticeship relationship. So in the case of surgery, I found that all of those practices that residents found, I call them shadow learners for this reason, involved bending or breaking rules of their profession or their institution. So just to make it very concrete, these are not like, oh, that's cool, they're a maverick, they came up with a different way to do things. This is, they operated on a patient with the senior surgeon out of the room. That should get your eyebrows to go up. Even the resident themselves are kind of like, well, this is not exactly right. Now, if you go read the paper, actually, you'd be somewhat comforted by this behavior because in many cases, that resident is better by that point than the person they're rotating to work with, for instance, in a subspecialty that's new to the robot. And in fact, that senior surgeon is objectively worse than the resident. So you'd rather the resident operate? That's how they get the shot. But bottom line, studying and finding those positive exceptions was really crucial for two reasons. One, we always figure out how to handle a new tech and we figure out how to build skill around it, but it tends to take 10 to 40 years. That's the rough amount of time. However, it is always logically true that somebody figured it out sooner than that, in part, at least. And it's probably systematically, independently being figured out, maybe 10 years earlier than the world gets it. So I'm trying to find that early success, unearth it sooner so that we can learn from it faster. That's part one. Part two, though, is that It's very strong evidence that what they're doing actually works to develop skill because they are sticking their necks out for it over a long period of time. They're risking either getting fired or losing status, getting in trouble, basically, for operating on a patient or learning from YouTube, by the way. All the very, very rapid, successful surgical learners spent 2 orders of magnitude more time on YouTube than those who didn't. That was viewed as wildly inappropriate.
Why was that inappropriate?
I'm going to quote and imitate in tone. I'm going to do an impression of a chief of urology at literally maybe the top teaching hospital in the States, or one of the top few, who said, "You can't learn to be an actor by watching movies." The assumption built into the research on surgical skill development and practice and culture is you learn by doing in the operating room with your sleeves rolled up side by side with a real patient on the table. That's the only way to do it. And so learning from simulation or video is viewed with disdain. Aviation went through this. Surgery is transitioning across this barrier. So at the time, anyway, that was viewed as inappropriate. And yet those who did it actually were the ones who built skill. But the period on that sentence is you can't imitate a deviant as a way to build skill. That is not the recommendation in the book. Breaking and bending rules is not what I'm here to say we should do. But if you look at what they were willing to bend and break rules to fight to preserve, then you've got something that's worth preserving. And that's the skill code in the front of this book. Challenge, complexity, and connection are actually the things under the hood empirically that they were operating on a patient without the senior surgeon in the room. That allows you to manufacture challenge for yourself so that you can struggle. So those 3 things are my best shot at what can we learn from those deviants that you could scale, that is applicable to a garden variety rule following adult.
Yes, I'm going to expand the word deviant, positive deviance, which is sociological, I guess, the concept of positive deviance, which is you look for variation in the population and you find people who, in the context itself, are succeeding in some way. And so because they're in the context, you know that it's not something that others in the same context can't potentially imitate. And so really, really important to do in context understandings of how people are being successful.
Right. And if you do this systematically and well, you can start to get at insights that transcend that context. And that's the skill code in the front of this book. So it took many empirical studies across surgery, warehousing, investment banking, beat cops, internet startups, and so on, to see that, in fact, the shadow learners in all those contexts were doing very different things locally, different specific practices, but that they were all scratching the same 3 itches: challenge, complexity, and connection. There were different means that were locally and culturally appropriate for securing those resources that any human being to build skill in context is going to require. So it takes a pyramid worth of insights that are locally justified to build that case.
There are a couple of behaviors that I want to call out in the positive deviance. And so one of them we just talked about was digital rehearsal, which was, for instance, looking at YouTubes. Another one is premature specialization. Can you describe that one?
Yeah, sure. So when you are in high school, imagine yourself in high school or perhaps in undergrad, but certainly by med school, if you were intending to become a surgeon someday. If you were in that context, you would find your way to getting your hands on the controls of a robotic surgical device in med school, say, to be conservative about it, and you're ducking your anatomy class or getting a B- on an exam in exchange. You are skipping parts of your generalist education to leap ahead and try to bone up on robotic surgery because you're just fascinated by that. Or you accidentally got dragged into a lab assignment with a senior person doing research on robotic surgery and got accidental exposure. You didn't really intend to. And then you end up having to teach little labs on how to run the simulator to residents who are 7 years your senior as a function of being an RA in that lab. And you walk out having the top score in the simulator. Didn't mean to, didn't really even care about robotic surgery. But by the time you leave that, and by the way, you're not done with med school yet, you are better than most residents ever will be. It's always because residents and med students have no time. This is what makes it deviant. You are sacrificing inappropriate swaths of your generalist education to get that hyper specialization. So people who were watching you locally at med school would try to kick you out in many cases for that kind of behavior.
By the way, we were talking earlier about the hyper specialization of the economy. Schools can't keep up with that. Schools are always going to be teaching a very gross anatomy of what you need to know in the economy. And to some extent, what you're talking about is all the things we do to bridge the gap between what can be attained by education. But in med school, you're still in the education box. And so to some extent, it's breaking out of that to get a higher resolution understanding of something that it can't possibly give you.
Yeah. This reminds me of one of my first bosses, actually. He was an irreverent and in many ways ineffective manager. But he said to me after about a week on the job, he said, "Now, I'll just give you one bit of advice. If you do everything we tell you to, you will be out of a job in 6 months." I'm that kind of a guy. I've always had a complicated relationship with rules and order and structure. So he didn't really need to tell me that, but it was a very useful reminder that whatever formal and informal curriculum, processes, structure was available, it was useful in some cases, and in other cases, I should deviate. And I will pay a price in some cases. I will get a gain, or others will pay a price, or others will get a gain. And it's all very uncertain. But if you go to med school and do exactly what you're told, you're just not going to end up being great.
You mentioned Hewlett Packard's award, and this is under the topic of cheating to learn, which was Hewlett Packard's gave an award for meritorious defiance. And I had never heard of that before.
Amazing. An incredible leadership act, actually, to create that award, because Chuck House was told directly by the founders of that company, do not go invest in building flat screen technology. We're going to go on vacation. Do not spend a dime on this. I know your customer wants it. Don't do it. And he said, okay, I promise I will not do that. And went away, appropriated the money without permission, had a prototype built. The customer was delighted and made their next 10 years of business for them. And so the founders of that company were in a little bit of a pickle, actually. So what do you do at that point? That was a fireable offense. Yet he had made a market for them. And I think actually the great innovation there is that they just chose to create, not just say, okay, fine, good job. And in many cases, that's what happens. They made an award out of it and gave it every year to somebody else following that. That's quite innovative. Takes a lot of presence of mind and guts, really, to realize, boy, the opposite of what we had hoped for is what we need as we grow, especially. So yeah, he was the first recipient. It certainly didn't survive through over the decades, but it was an institution that lasted quite a long time.
One of the things you mentioned that the positive deviants do is unsupervised struggle. What's that?
Under-supervised struggle.
Oh, you see, I mistranscribed it. Under-supervised.
Yeah, under-supervised struggle. And that one took a lot of thinking because, I mentioned a resident operating on a patient without the attending surgeon in the room. Those who were successful were very careful to arrange it such that they could get access to that expert if and when they needed to get support if they got in over their head. And or that expert was in a position to intervene themselves if the resident didn't notice that they were getting in over their head. So practically, this meant that, say, the senior surgeon left the room for a little bit, but they said, just page me if you need me. When I was in the operating room and I saw this happen, that's almost always what would happen. I'm going to go get a coffee, page me. And for the next hour and a half, the resident would struggle away. And that was up to that resident to page. But also, there is a nurse in the room. There is a scrub tech in the room. And those professionals have worked on, say, 2,000 procedures, more than maybe even the senior surgeon. And if they see something going sideways, they're not going to stand by and watch a student, a resident, injure that patient. So they'll just call the attending. So there are numerous safety buffers where it's actually practically impossible that the resident would end up creating severe trouble. So that's the under supervised bit. And I talk about the inverse of this in the paper, which I call helicopter teaching, which is if you were in an operating room, if I brought you into a robotic surgical procedure, you can picture a resident and a surgeon, each at a control console. One of them, the resident, now has control of the end effector, that robot. They're using that control console to operate. Their view is broadcast on televisions, widescreen TVs around the OR, and the senior surgeon can see that too. The only way the senior surgeon can give feedback to that resident is to yell at them. They could have used all kinds of nonverbal and quiet communication at the bedside, but so you're getting all kinds of yelled feedback on tiny, like millimeter scale movements inside the patient, and you get pulled out of the pool very quickly that way. There's no challenge there. And the opposite basically is you are not unsupervised, you are under supervised, but you can pull it in or it will be pulled in on you if there's serious trouble.
I have run very learning-oriented organizations that are based upon apprenticeship. We actually have essentially the equivalent of a guild, and we have different levels in that guild. And the most senior levels have a large teaching component to what they do. And this is in the process world. So there's black belts, green belts, yellow belts. And the thing is, what you're doing is you're scaffolding people through the different levels because it takes a lot of flight time to learn how to do that. And different members of the learning of the novice community demand different levels of supervision. In other words, there are some that want all the answers given to them. And there are some who aren't going to listen to your answers, even if you tell them. And I'm sure there's a sweet spot in there because there's a way in which neither end is learning.
I talk about this in the book that I put a 10-point checklist for each of those 3 C's that make up the skill code in the book, according to the science. And one of them is in challenge in particular, that an expert is there to help you moderate your connection with challenge and with complexity and with human connection so that it's optimal for you. This is the old 2 Sigma paper and problem. A one-to-many relationship here is just not functional because each person's capabilities, interests, motivation, and so on just vary. And it's only in the doing of the work that the expert gets the rich data that they need to assess that individual's need for, say, frustration management is a part of this healthy scaffolding. Like, as a novice, it's just frustrating. It's uncomfortable to be challenged. And an expert can really help you manage that frustration so that you can go further faster. Basically, you learn radically better with one-on-one attention than you do one-to-many. And that's been the classic problem that HCI as a discipline, human-computer interaction, was broadly enabled and born on the back of that problem. Online education as a problem, as a mechanism, a lot of that work has been to try to solve this 2 Sigma problem. How can we create conditions that are equally conducive to learning, but that don't require one-to-one interaction?
Got it. I've always thought, I wish I could have learned like Wittgenstein. He just had essentially professors one-on-one from childhood,
Which means money.
Well, yeah, it meant money. It meant money then, too. So you go on to make a number of recommendations, and they are to different members of this system of skill transfer. One is for the novices, one is for the experts, but you have 2 that we haven't talked about at all. If you are in management, insist that productivity and human capital development are not at odds. What do you mean by that?
That's a fun one. I have some more data on that one now than I did when I turned in the manuscript for this book. As you might imagine, since the book came out in June, I've had a fair amount of contact with senior execs who are making big decisions about, say, 10,000, 20,000 licenses of whatever form of generative AI, pick your flavor, in their firm. And the big question is, how do I do this so that it's valuable, right? And I have given them a new question to ask in addition to that one, which is, fine, we're going to hope for some productivity here, and we'd like some grounded hypotheses as to why and where we might get some productivity gain by deploying this tech, so we can be intelligent about deploying this stuff. And, dear tech vendor, can you tell me that just by using your system, our employees will slowly and subtly upskill themselves over time. And so I don't yet have reports back. So this is all very new, but I think, major vendors will go, huh? And that's right and good. Of course, they haven't been optimizing for that, but there are trivial UX changes compared to the cost of training a model and building these systems. Trivial UX changes that you could make that would leave a user more liable to have built skill by the end of a usage session or by solving a problem with these tools than before they started, including, by the way, human connection. So all three C's that I mentioned, you can have the UX of these systems drive healthy challenge, complexity, and connection. It is mildly irritating, as best I've been able to simulate it, in the same way that a real mentor is mildly irritating to a novice. But purchasers are in a very powerful position now to say to vendors, well, fine, you have 2 weeks to go away and come back with some proposed design changes or experiments that we could run to modify the base UX of your system such that just by engaging it, we would both get productivity gains and that usage would subtly drive skill investment in the same way that investing in your 401k would subtly drive your retirement income. And I think that is a healthy, feasible goal. And the first major vendor to jump on that as a problem will win in the marketplace. It is obvious to me because everybody's anxious about the human cost of implementing these systems. So I think that people with purchasing power at scale right now have a particularly potent role to play in shaping how these systems affect the human capital within firms.
I couldn't spell when spell checkers came out. I was terrible at spelling. But now I'm actually pretty good at spelling. And the reason is that spell checkers have been teaching me all this time by saying, this is wrong. And I look at it and I can't really see how it's wrong in many cases. And then I say, okay, correct it. And it shows me right. And so that's enough that over time, I have become proficient at that. Statistics packages are not doing that for me. I couldn't write the chi-squared formula. I don't know what that is. I say equals chi-squared in Excel, and I never see the actual calculation. And so it's like that, right? It's like exposing people to things that are going to less black box, maybe.
I wrote a sort of first pass attempt at this out in a post on my Substack called Don't Let AI Dumb You Down last October. That reflected an experiment I ran with my master's students in a class. And in short, I think there's a meta layer of refactoring that you can do that goes beyond the auto suggest. That kind of feedback you're just describing is really useful over time, but doesn't obviously and necessarily drive skill development. It can. I have, for instance, a set of custom instructions that you can drop into, pick your commercial LLM of choice around guidelines for interaction that you can input. Here are my goals in life, basically, and here's how I want you to treat me differently because of these goals. You have 2 boxes in all these systems. And if you state, which I do in those boxes, I value skill development as well as my productivity, and that skill development flows from challenge, complexity, and connection, defined the following ways. And in the second box, here's how to interact with me to drive challenge. And I have those 10-point checklists in the book. And so I've just operationalized those in that text. And now dealing with, I wanted to build some code to predict when rocket boosters would land at Vandenberg Space Force Base after SpaceX launches satellites. Because they don't always, and it's really exciting to watch. My wife and I like to go watch them. And I didn't really know how to do that. And because of those custom instructions, a system I was using said, I can give you the code. Sure, you don't want to try a little bit? And by the way, I get it. You're curious about this. Are there other human beings within 20 miles who might also be curious that you could connect with about this? Maybe people you could meet with at the landing site, and how might you connect with them? So because I said I value connection, which is a warm bond of trust and respect between humans, and that will drive my skill development in the following ways. Systems like these can and should prompt us to disengage with them and re-engage with human beings to maintain and deepen those relationships. And by the way, that's just one guy trying to refactor the system as an end user. The power that a tech vendor has is profoundly greater than that, economy scale implications. And so if managers start to insist on some kind of solution, let's try something somewhere to get both. Why can't we have both? It seems possible. And if we don't try, we can't know. And there will be cases where, no, it is not appropriate or feasible to insist on skill development and productivity at the same time. That's fine. But in all cases, that's our default response. That's ridiculous. That's a huge wasted commercial opportunity and leadership opportunity.
This leads us to measurement. How does measurement and your current views of measurement play into this opportunity?
I'll skip straight to the end here and work my way backwards. I will announce in about a week that I am CEO and co-founder of a startup called Skillbench, which is developing a cost-effective means of predicting and then measuring after the fact the productivity and skill development effects of implementing generative AI within firms on a cost-effective basis compared to previous alternative methods, using AI itself to do that. That is, I think, the base problem that we have in addressing this issue. So we've been talking for a while about this threat to the basic engine of skill development at work that comes with separating experts from novices. The problem is invisible currently to most. The minute you mention it, has face validity. People go, okay, that sounds good, but reasonable managers need data to draw conclusions, make predictions, and so on, and also need a good theory for that. And we've been doing some foundational research on how humans respond on a very fine-grained basis to using AI in various valuable work streams, what they're liable to automate away, and what the consequence of that is for their productivity and skill on a very fine-grained basis. We're automating that, and we'll make that platform available to firms so that they can predict on a very fine-grained basis what will happen. And in many cases, this, I hope, will give firms the ability to make much more intelligent decisions about this, where they can balance, jointly optimize the productivity gains and the skill development question. So I've been working with my co-founder, Joo-Ho Kim, who's at KAIST right now in Korea, sort of Korea's MIT equivalent. He also came out of CSAIL at MIT. We've been working together for about 4 years, pretty quietly, publishing papers in surgery, actually, but developing the engine underneath that allows for our transition into the corporate space now. But it wasn't apparent to me that the world needed a new metric while I was writing the book. I turned in the book and then realized only recently that, in fact, a cost-effective metric will help the world see the problem clearly and compare it to all the other problems that are relevant to deploying this technology so that we can just make intelligent decisions. In some cases, it will be true, objectively, that you get such huge productivity gains that any skill loss is just not worth trying to fight for. But that's like one of the cells in that 2x2. Like if you have high productivity gain, low productivity gain, high skill development, low skill development, or even deskilling, where and how different deployment patterns are going to fit in there, we just need empirical data. So I have become a measurement guy in that sense. I think that that's the thing that I can do that's most valuable. Let's put it that way.
The really critical thing, if you can pin it down, because that's going to be in a fight between people who want results in a quarter and people who want results over 2-3 years. And to the extent that you can show the value of learning within financial time or near financial time would be really compelling.
Yeah, and we're trying to start in places where that case is easier to make, to be candid. For instance, when margins are high and talent is really mobile, and as you said, people make opt-in decisions or stay decisions based on whether I'm learning and growing. Is this interesting to me? And by the way, we have a lot of experience with AI, and I'm already starting to hear from my junior devs, for instance, that they're not getting a chance to play anymore with the code. And senior folks are saying, I can't even trust this person to touch the code now because they don't know what they're doing anymore. Especially as I talk to folks in advanced software firms. They already have anecdotal data about this problem. They recognize that those junior devs can just go somewhere else. So it doesn't matter that that's not a dollars and cents indicator to that firm. Well, it is in attrition and training and turnover.
That's very aligned with the thesis of this show, as a matter of fact, that learning has value to employees. It is a value produced by the system. So I ask a couple of closing questions of everybody. And the foundation of these questions have to do with the idea that I believe work is a product that companies sell to employees. And so I ask product marketing questions about your work and what it gives you. And the first question is, what job does your job or your work do for you?
Makes me feel like I'm making a difference, the best difference I know how.
There's many kinds of differences that you could make. What does this one do for you?
So, best, brightest possible future where humans bring the best out in each other and the tech that we use, where we have great flourishing in the human side of the ledger and even greater flourishing in the technological side, like a yes and. I grew up on deep, glossy, imaged science fiction as a kid. And of course, like many nerds these days, I'm a giant fan of the Culture series. There are really complicated, lovely science fiction, messy, but beautiful, complicated futures that I've imagined since I was a little kid that seem well within reach if we are aggressive about creating a future that is not just about some reduction in entropy and humans be damned, but that why couldn't we create a future where it's just general human welfare and particular human welfare is improved and increased? It's just better to be alive. And because of that, technology becomes radically more awesome. Somehow, I think we have this cultural code that I just hate, which insists that you can only have one or the other. It just seems foolish. It seems like the only way to get great in both is to insist on both.
I want to call out the Culture series by Ian M. Banks, which you just mentioned, so that it ends up in the show notes. Some of the best science fiction ever written. So I wanted to call that out. You know what's really interesting about a multidisciplinary department is that it can look at flows of value that are more multidimensional, it seems to me. It can think about not just how do we deliver some technology or how do we fix society, but rather how do we get these multiple things to work together in a collectively beneficial way. So fantastic to hear about that program. What does your work cost you?
I don't have kids. I love kids. And I don't think it was necessary that my wife and I were going to have kids. Maybe after about 7 years of marriage, we looked at each other and went, no, we don't need to do that. But could have. And I nuked a career to go back to school. So if I had not done that, I think we might have. I think we might have been great parents. So it's not obvious that I couldn't have done both, but I am quite occupied with work. And I am grateful for the life I have, but I think of that one occasionally. So if I had to pick one cost, adopting kids is something we talked about a lot. Fostering kids in another universe, that would have happened and our lives would have been better on some dimensions. Going through my PhD program at MIT was excruciating. That was extraordinarily stressful. My choice, but I lost a little vision in my left eye as a result. I got something called central serous retinopathy. The stress was very intense. It's mostly recovered, but that took a toll. But cry me a river. Those are sacrifices, but I got to choose to make those sacrifices. It was all elective surgery. Was born of not as much as some, but immense privilege relative to the base population of the planet. So I find those are sacrifices. Sacrificing connection across socioeconomic divides. I've worked very hard to do field work because that keeps me in touch with real folks who have to worry about rent and generally get the shaft from society and organizations. I think that's important, but still give me a break. I mean, I'm in the ivory tower. That's challenging, frustrating. My wife and I both prefer to live in areas that are mixed socioeconomic backgrounds and diverse. And we live in Santa Barbara, which is amazing, but not ideal from that point of view.
What's interesting about those costs, they're aligned with costs that I've heard from other people I have talked about this with. There are a lot of people who have kids, and yet their work did not made it so that they couldn't spend time with them. And so they are saying something very similar despite having kids. And I also think that it's partially because of who I interview. I very rarely run across people who describe physical injury. But if you were to talk to people about what work costs them, they would say, look at my finger. It's gone. There's a lot more of that in work than usually comes out in my interviews. Where can people learn more about you, about your work, about your book?
One-stop shop is www.mattbeane.com or theskillcodebook.com. Either one goes to the same site. There you can find the book. There you can find a link to my Substack that I mentioned before. I essentially have something between, 10 and 15, the equivalent of a seed of a chapter for that book that I couldn't have written during the book. So sort of continuations on a theme, nothing regurgitated from the book. My daily droolings are on Twitter, and there's links to that from that site too.
You're going to launch this company in a couple of weeks. Is it going to have an independent website?
Skillbench.com.
Great to have you on the show.
Yeah, it's my pleasure.
Great, really important add to the conversation we're having in the podcast.
I'm glad to hear it. I really appreciated the invite, especially given the work that you do. I feel like we could do it in reverse, and I selfishly would want to learn a lot more about what you're up to. It's a rare treat to get to have this kind of conversation. You obviously read the book very carefully, but you're at the coalface in a consequential location on these issues. So it's really fascinating to have the chat.
Thank you. Thanks for joining me for another episode of Work for Humans. If you enjoyed this episode, please give us a 5-star rating wherever you listen to podcasts. And share the show with one person you think would get value from it. Believe it or not, this really helps us grow the show and reach more people who want to build the kind of work that people really want. As always, thank you to my producer, Jason Ames at Ninth Path Audio for his insights into content and his high standard for quality. Final note, the opinions shared here are my own and not the views of Google or Cisco Systems. Thanks again for listening. See you next time.